All right, this video is going to go over how to find integrals with rational functions using partial fraction decomposition. So we use this method whenever the degree of the bottom is larger than the degree of the numerator. So denominator degree bigger than the numerator. Again, if the numerator degree is equal to or greater than the bottom, use long division first. Okay, but in this case, I need to break this up into whatever its original fraction was that made this combination. And you do that by finding the factors at the bottom. So I see that the x cancels, or x factors out. And then I have x minus 2, x plus 1 as my factors here. So what does that mean? That means that the rational function 3x plus 2 over x cubed minus x squared plus 2x must be equal to some number over x plus some other number over x minus 2 plus another number over x plus 1. And notice all of these are numbers. I use ABC instead of lots of different A's. And then what we would do to solve this for A, B, and C is you would multiply through by this denominator on both sides. Well, then any factor that is in, like we're multiplying by this, right? So any factor that's included gets canceled. Like in here, these get canceled. And so A ends up having just the other two factors that stick with it. B ends up having the other two factors that stick with it. And C has the other two factors that stick with it. Now, I personally use something called strategic substitution in order to find my A, B, and C. There's a couple different ways you can do this. I use strategic substitution, especially when I have distinct linear terms as my factors. And so I say, okay, if x equals 2, then this whole thing ends up being 0, and and this ends up being 0. So I could figure out b, because this has to be true for any x value, so I get to choose. So 3 times 2 plus 2 means that 8 must be equal to b times 2 times 3. So b must be 4/3. If I let x be -1, then these ones are going away and I can solve that for C. So I plug that in, I get -1 equals C times -1 times -3, or C has to be equal to -1/3. If I let x equal 0, then I get 2 must be equal to A times -2 times 1, or A must be -1. All right, I'm going to come back up here to the top and write this all now as my integral. So this must be the integral of A is -1 over x plus B is 4/3 over x minus 2, and C is -1/3 over x plus 1. All right, so I went ahead and just erased all of that. Okay, so then I'm going to integrate each piece. So I have negative natural log of the absolute value of x plus 4/3 times the natural log of x minus 2. And I don't have any term in the front here, so I don't have to worry about, those are just 1, so I don't have any factors I need to multiply by on the outside, or do like a u sub. It's okay to just have those pieces there. And then plus C. And we can just leave it like that. It is possible for you to combine these with log rules if you want to. That's going to get a little bit messy. So for the sake of this video, we're just going to leave it like this. Okay. All right, so what happens if you end up having a repeated linear factor? So if you look here, I already have this in factored form for us, but it is possible that this rational function came from something that had just 2x minus 1, but then also another denominator that had 2x minus 1 squared. Because a times 2x minus 1 over 2x minus 1, you would end up getting that common denominator. So when you have a repeated linear term in your factors of your denominator, you have to include each like factor level within your solving. All right, so that means that x minus 2 must be equal to, now I'm multiplying through by my denominator here. So a gets both a 2x minus 1, because it's a 2x minus 1 squared, and it gets an x minus 1. Now, b only gets an x minus 1, because if I multiply through by 2x minus 1 squared, it already has both of those in the bottom. And then c gets a 2x minus 1 squared, because it has an x minus 1. All right, let's do some strategic substitution. The first one I'm going to do is 1/2. That's going to get rid of a and c. I'm going to have negative 3/2 equals b times negative 1/2. And that is only true if b is equal to 3. So let's go ahead and say I know that b has to be 3. Okay, if I let x equal 1, then I get rid of a and b, and I'm left with just c. So I have negative 1 equals c. When I plug in 1, I get 2, 1 squared, so c equals negative 1. Purple. Looks great. Okay, now there isn't anything I can do here, right, to solve. I already have the other zeros to solve this for a. So I'm going to have to plug in and do a secondary method to solve this for a, because I know b and c, but I can't use the strategic plugging in to find a, because I already had the zeros all taken care of. So let's see. I know that x minus 2 equals a times 2x minus 1 times x minus 1 plus 3 times x minus 1 minus 2x minus 1 squared. So this is the second method that you can use to solve this. It is called method of equating coefficients, because I need to figure out what a needs to be in order to make this true. Now, one thing we need to do is we need to expand this and then also multiply by a. So this is 2x squared minus 3x plus 1, and then I need to multiply through by a. Over here, 2x minus 1, so this is 4x squared minus 4x plus 1. So x minus 2 has to be equal to 2ax squared minus 3ax plus 1 plus 3x minus 1 minus 4x squared plus 4x minus 1, because I have a minus here, so I need to make sure that I pull that through and sorry, and apply it to each and every piece there. All right, if I do that, then I see I have a 0x squared here, right? Like I don't have an x squared term on my left-hand side, and these have to be equal to each other. So that means that whatever is in front of my x squared term here and x squared term here must cancel out, because I don't have any x squared term on my left-hand side. Well, that only happens if a equals 2, right? I could set this up 0 equals 2a minus 4 and solve that for 4, because I need just those numbers in front of your x squared to be equal to 0. So that's one option that I have. The other option that I have is I know that negative 3ax plus 7x must give me 1x. Let's just make sure if a equals 2, is that true? -6 plus 7 equals 1. Yes, this is definitely true. Now you could also plug in like other random numbers. Like I could say like, oh, what if x is 0? Like it's not a 0 over here, but like once I know that b is 3 and c is -1, another option is go ahead and write this all out and then choose like another like easy 0, if you will. So if you haven't already used x equals 0, you could do that. You end up getting a equals 2. So that's kind of another like strategic substitution you could do, but it's not as like clear as using a 0 of one of these, okay? All right, so let's go ahead and write our integral. We would have the integral of, now 2a is over 2x minus 1 plus b was 3 over 2x minus 1 squared plus c was -1 over x minus 1. Okay, u sub this one here. If u equals 2x minus 1, that's going to be 2 over u. I do need to have a 1/2 in the front. So this integral, keep the 2. Oops, I don't need the integral sign. I'm about to integrate. Okay, so keep the 2. And then it's 1/2 natural log of 2x minus 1. Now here, I'm going to let u be that same thing, but this is not a natural log, okay? This is 3u to the -2. So I need to add 3. I still have times 1/2. But then this is u to the -1 over -1. And then my last one here is going to be -1 natural log of x minus 1 plus c. Now, it wasn't my intention to have to do a second video on this, but it looks like on my timing, I'm going to have to. So watch the second video to get our last example.